A steel ball weight 2 pounds is dropped from a height of 3,000 feet with no velocity. As it falls, the ball encounters air resistance numerically equal to V over 8 in pound, where V denotes the velocity of the ball in feet per second. So, the information we got from the question is a steel ball with weight 2 pounds is dropped from 3,000 feet. The other information when the ball is dropped is weight are going down and air resistance are going up. Also, the force are going down and everything follow physics Newton's law. From the information we got, we can just simply substitute 2 for W and 32 feet per second into G, and we get M is equal 1 over 16. The important part is Y Cartesian is equal to MA. By doing vector calculation, we get R minus W equal negative MA. W and MA are negative because it goes down. So, by this equation, we can just substitute everything into this equation, where R is 1 over 8V, W is 2, M is 1 over 16, and A, just like simple calculus, is dividity. Once we substitute everything in, we just need simply divide everything with 1 over 16 and we get 2V minus 32 equal negative dividity. So we arrange everything and we get dividity as 2V equal 32. So is equation what we want. By this equation, we can just get information of P and Q, where P is 2 and Q is 32. So once we get this information, we can just do simple integrating factor. So integrating factor is E power of integrate P dt, where P is 2 and we get E power of 2t. So once it done, we can complete the solution, where V time integrating factor equal integrate Q time integrating factor dt. And we can see here VE power of 2t equal integrate 32e power of 2t dt. So once we done integrating, we can get VE power of 2t equal 16 E power of 2t plus C. But this is not the final answer because this is a general solution. So how do we get particular solution? So we just set T and V is equal to 0. So once we done substitute, we get C is equal to negative 16. So we just simply substitute negative 16 into C for the general solution. So we get V equal 16 minus 16 E power of negative 2t. So this is the particular solution. So after we got the particular solution, so we can just find the limiting velocity for the ball. So the first step what we need to do is we just set the limit t is equal to infinity. So we just simply substitute infinity into t and we get v is equal to 16. When v is equal to 16, so the limiting velocity is 16 feet per second square.
Question B. The time required for the ball to hit the ground. Based on the previous answer, which is Vt equals to 16 minus 16 e to the power of negative 2t, we can consider the Vt also to the dx over dt. To find the time required, we need to find the x equation first, which is we need to integrate both sides, integrate dx over dt and then integrate 16 minus 16 e to the power of negative 2t. From here, we will facilitate the word calculation. Then, we will let u equals to negative 2t. We will get dt equals to negative 1 over 2 du. Here, we will substitute the equations into the equation. We know that u equals to negative 2t and dt equals to negative 1 over 2 du. After that, we will simplify. We will get 16t plus 8e power of u plus c. The equations of xt is equals to 16t plus 8e to the power of negative 2t plus c. Here, we want to know the value of c by substituting t value which is equals to 0. Based on the questions, a steel bar dropped from a height of 3000 feet. So we know that the xt, also known as height, is equals to 3000 feet. We substitute the 3000 into the equation and then we simplify by dividing everything to add. We will get 0 equals to 2t plus e to the power of negative 2t minus 376. To find the t value, differentiate the equations and then we will facilitate the word calculations by separating it. When we differentiate 2t, we will get 2. Differentiate e to the power of negative 2t, we will get negative 2 e to the power of negative 2t. And then we differentiate negative 376, we will get 0. We will simplify the equations and then we will get e to the power of negative 2t equals to 1. Now, we know that this value we can simplify carried from here. Here, we will get the e to the power of negative 2t equals to negative 2t plus 376. We will substitute this value into here. Negative 2t plus 376 equals to 1 and then we will get e equals to 1 at 7.5. Rounding it off, we will get t equals to 188 seconds. The time required for the ball to hit the ground is equals to 188 seconds.
A 50-gallon tank initially contains 10 gallons of fresh water. At t equal to 0, a brine solution containing 1 lb of salt per gallon is poured into the tank at the rate of 4 gallons over mean, while the well-stirred mixture leaves the tank at the rate of 2 gallons per mean. Find A. The amount of time required for overflow to occur. B. The amount of salt in the tank at the moment of overflow. Initial condition is T is equal to 0, V0 is equal to 10 gal fresh water, which is S0 is equal to 0. And then E is equal to 4, B is equal to 1, F is equal to 2, and C is equal to S over V0 plus E minus FT, which is, this is the given information that we get from the statement. Okay, before that, I will tell what is the meaning of E, B, F, and C. So, the meaning of E is the rate of solution goes in. The meaning of B is the initial concentration. The meaning of F is the rate of solution goes out, and the meaning of C, which is the final concentration. So, firstly, let ST is equal to amount of salt at time. Then we differentiate it, and so it be ds over dt is equal to EB minus FC. Then we substitute it and we get ds over dt plus fc equal to ev. Okay, so next, from the given information, which is c is equal to s over v naught plus e minus f multiply t, change it into the c in equation. So we get, based on the given information that we write, we put into the equation, and then we get ds over dt plus 1 over 5 plus t multiplied by s equal to. Okay, for next step, we need to do integrating factor. For integrating that factor that we use is 5 plus t. So we put it into the equation, then we get 5 plus t multiply ds over dt plus s is equal to 4 times 5 plus t. Then we need to integrate the 5 plus t s. We get 5 plus t s, and at the right side 2t prime plus 20t plus c. Get s is equal to 2t square plus 20t plus c over 5 plus t, where c is equal to 0. And then when we put the value of c, which is 0, and we get the value of s is equal to 2t prime 2t square plus 20t over 5 plus t. Question A, which is it want to find the amount of time required for overflow to occur. Then we need to use the formula Vt is equal to V naught plus E minus F T. T is equal to 50, V naught is equal to 10, E, which is the rate of solution goes in, which the value of it is 4, and F, which is the rate of solution goes out, is equal to 2. So, and then we get time required for overflow to occur is 20 minutes.
For question 2b is find the amount of salt in the tank at the moment of overflow. Through the calculation and information obtained from question 2a, we have the equation that is the equation of amount in LB of salt at time, that is St equal to 2t squared plus 20t over t plus 5, and has the amount of time required for overflow to occur. It is t equal to 20. To find the amount of salt in the tank at the moment of overflow, we only need to enter the value of t equal to 20 into the equation amount in LB of salt at time. So we get S20 equal to 2 times 20 squared plus 20 times 20 over 20 plus 5. So we simplify the equation to be this: 800 plus 400 over 25, 1200 over 25. After simplify the equation, finally we get a value of 48 lb, which is the amount of salt in the tank at the moment of overflow.